Hey everybody, and welcome to SpaceWeek for Monday, December 23rd, 2019. It's been an eventful week, with 5 rocket launches, a failed orbital insertion, lots of press conferences, and a crew capsule landing on airbags. China kicked things off with a Long March 3B launch carrying 2 more Beidou 3 navigation satellites to medium Earth orbit. Later in the week, they also launched a Long March 4B with the Seabirds 4A China-Brazil Earth Resources Imaging Satellite into a sun-synchronous orbit. The SpaceX Falcon 9 successfully launched the Pacific 1 broadband communications satellite into a geosynchronous orbit over the Asia-Pacific region. As the 2 payload-faring halves descended toward the ocean, SpaceX tried to catch them with their twin ships Ms. Tree and Ms. Chief, each of which has a 200-foot net suspended over the deck. Unfortunately, they didn't manage to catch the fairings, which splashed down in the salty water. SpaceX retrieved them and will refurbish them for a later flight. Arianespace sent up a Soyuz rocket with the Italian Space Agency's Cosmos SkyMed second-generation radar surveillance satellite, the European Space Agency's Cheops satellite to study exoplanets transiting their stars, and 3 small satellites called ISAT, OPSSAT, and ANGELS. The Soyuz's launch profile was complicated, deploying the satellites at 3 different orbital altitudes. First, CSG-1 at 633 kilometers, then dropping down to 449 kilometers before rising back up to deploy Cheops at 709 kilometers, then dipping down again to deploy the CubeSats at 522 kilometers. It all went off without a hitch. You may be wondering why the French launch provider Arianespace is using Soyuz rockets. Aren't those Russian? Why, yes they are. Arianespace buys their Soyuzes from Russia in order to provide a medium lift launch capability to their customers. Arianespace's own rockets are the Little Vega, the heavy-lift Ariane 5, and the upcoming medium heavy-lift Ariane 6, which is scheduled to launch sometime in 2020. Finally, we get to the big show, Boeing Starliner. If you're familiar with SpaceX's Crew Dragon, Boeing Starliner is its more expensive and less glamorous cousin. Boeing and SpaceX independently developed these crew spacecraft as part of NASA's Commercial Crew Program. Since the Space Shuttle fleet was retired back in 2011, all human spaceflight has been conducted by way of Russian Soyuz rockets launched from Kazakhstan. Starliner launched on Friday atop a United Launch Alliance Atlas V rocket with 2 solid propellant side boosters and a dual-engine Centaur upper stage. The launch profile for Starliner is similar to that of the retired space shuttles. It's inserted into a suborbital trajectory by the rocket, and then it uses its orbital maneuvering and attitude control thrusters to finish its orbital insertion. Which brings us to
the term of the week.
Orbit insertion is a maneuver to adjust a spacecraft's momentum, either accelerate or decelerate, to put it into a stable orbit. In the case of many Earth-orbiting satellites, or spacecraft bound for the ISS, the rocket doesn't actually deliver them to their final orbits. What the rocket does is deploy them in an elliptical transfer orbit that will carry them up to the correct altitude, at which point the spacecraft performs an orbit insertion burn to circularize its orbit. Getting back to last Friday, the pre-dawn launch of Starliner was gorgeous, and the Atlas V rocket performed perfectly. Once Starliner separated from the Centaur upper stage, though, things started to go sideways, literally. Like Crew Dragon, Starliner was designed to be largely automated. The craft is supposed to know where it is in space, where it is in its mission, and then intelligently perform the appropriate maneuvers according to the mission parameters. For reasons that are yet to be determined, though, Starliner's mission-elapsed timer was a full 11 hours off. That is, Starliner thought that it was 11 hours further along in its mission, long after it would have performed its orbit insertion burn. As a result, rather than doing an orbit insertion burn, its RCS thrusters started flailing essentially, as the craft tried to figure out how to get where it was supposed to be at T+11 hours. NASA tried to issue corrective commands, but the commands weren't received in a timely manner because Starliner wasn't synced up with the Tracking and Data Relay Satellite System, or TDRS, whether because it was outside of the coverage area, or because it was misaligned, or some internal problem. By the time NASA regained control of Starliner, it had burned through a quarter of its fuel. They did manage to stabilize its orbit, so there was no risk of an uncontrolled entry into Earth's atmosphere. With only 75% of its maneuvering fuel remaining, though, it fell outside the allowable parameters for docking with the ISS. It would never reach its intended destination. NASA and Boeing decided to circularize Starliner's orbit at around 250 miles with an unscheduled orbit insertion burn. Then on Sunday safely deorbit it to land at White Sands Space Harbor in New Mexico 6 days earlier than originally scheduled. While Starship was up there, they ran a series of tests and simulations to validate as many of the ship's functions as they could without actually docking to the ISS. Early Sunday morning, bundled up against freezing temperatures in the pre-dawn desert, the recovery crew waited in their convoy of trucks. Despite its orbital troubles, Starliner performed beautifully on deorbit entry, descent, and landing. All 3 main parachutes opened, unlike during their pad abort test a few weeks ago. The heat shield jettisoned, the airbags inflated with nitrogen, and Starliner touched down right where it was supposed to. It took the ground crew a little more than an hour to get the hatch open, which isn't great, but SpaceX took a similar amount of time with Crew Dragon, which splashed down in the Atlantic. Veteran astronaut Sonny Williams, who will command the first human flight of Starliner, was on site at the landing and christened this Starliner craft Calypso, after famed oceanic explorer Jacques Cousteau's research ship. In the end, Boeing Starliner's maiden voyage was at least partially successful. The Atlas V flew for the first time without a payload fairing. Starliner's aeroskirt worked to keep the turbulence off the rocket. After the mission timer glitch and tedious uplink delay, NASA was able to regain full control of the craft. The orbit was stabilized and then circularized. All the on-orbit tests that could have been done were completed, and Starliner deorbited and landed perfectly. Some rather polarizing commenters have said that since Starliner failed to reach the ISS, the mission was a total failure. This simply isn't true. Not only were most of the mission objectives accomplished, but had a human crew been on board, they wouldn't have been in any danger. The craft never lost power, it was never at risk of deorbiting, the climate control and life support systems worked fine. In fact, had a crew been present, they would have been able to take direct control of the craft and get it back on track, which is precisely what they're trained for. They probably would have arrived at the ISS right on time. Furthermore, Steve Stitch, deputy manager of NASA's Commercial Crew Program, pointed out that there's actually no requirement for Starliner to automatically dock to the ISS on an unmanned test flight before getting crew certified. Remember that the space shuttle didn't dock automatically either, and it couldn't even fly without a crew. NASA Administrator Jim Bridenstine mentioned that had they been able to issue their commands to Starliner immediately, they may have been able to correct the mission-elapsed timer and initiate the orbit insertion burn. While that's speculative, the point is that test flights are just that, tests. And both NASA and Boeing learned a lot from this one. The real tragedy, said Bridenstine, is the Christmas presents. At least the crew can still pick them up when they get back home, and they aren't vaporized in the atmosphere. The anomaly does raise some questions about the path of Starliner going forward, though. Asked if there would be another unmanned orbital test flight, Jim Bridenstine said that it's too early to know. First, they need to find the root cause of the timer issue. Jim Chilton, who has the lengthy title of Senior Vice President of the Space and Launch Division of Boeing Defense, Space and Security, said that even if everything had gone swimmingly, they would still need to look at all of the data before deciding when to move ahead with a crewed launch. He said they could be done with their data analysis by late January. Now that that's settled, let's talk about this week. There's actually not much on the calendar. 3 launches, but none of them will have live coverage. On Tuesday, December 24th at 7:03 a.m. Eastern, 12:03 GMT, a Russian Proton will launch the Electro L3 geostationary weather satellite. On December 25th, the crew of the International Space Station will be celebrating Christmas without any presents, thanks to a very confused mission-elapsed timer. On Thursday the 26th at 6:12 p.m. Eastern, 11:12 GMT, a Russian Rokot rocket with Breeze KM upper stage will launch 3 GONETS-M communications satellites. And on Friday the 27th at 10:21 p.m. Eastern, 3:21 a.m. GMT on the 28th, a Chinese Long March 5 will launch the Shijian 20 communications satellite. That's it for this week. Thanks for watching. As always, feel free to like, subscribe, and activate notifications if you don't want to miss anything. If you enjoy content like this and you'd like to help out, there are Patreon and PayPal links in the description. SpaceWeek is also available as an audio podcast at rawspace.podomatic.com and on iTunes at tiny.cc/spaceweek. See you next time. Season's greetings and Merry Christmas to you all.